Hello, my name is Ogden Stefanovic, and for my project I made a heart rate monitor.
So the main two components of our circuit is this infrared LED, which is currently on, and this infrared silicon photo transistor.
Pause the video at any time and have a better look at the circuit. Basically, this is my input from the collector junction of my photo transistor. This is a high pass filter. This is an on-amp based low pass filter, with basically this impedance being and this impedance forming a potential divider on the inverting input. This is my second stage amplification, and I took my previous V out and added a 5K variable resistor so I can set my gain to whoever I like. And this second part is exactly the same as the first part of the circuit, the first stage. I just added a red LED which will be in sync with my heart, and I've added a buffer here for good measure.
This is my built circuit. It's currently not plugged in. This wire powers up my circuit. Without going into much detail, this is a DC to DC converter which basically gives power to my op-amps. Here's my photo transistor and LED to which I can stick my finger to get measurements. This is first stage of amplification, this op-amp. This is my 5K potentiometer with whom I can set the overall gain of my circuit anywhere between 0 and 10,000, so I get a good signal to noise ratio so that my signal isn't noisy when I'm not actually measuring anything. This is the second stage amplification, from which I can take my output and connect it to the probe of my picoscope to get readings on my PC. Okay, so I'm now measuring my pulse. Okay, now we can analyze the graph that I got.
I've selected these two peaks. You see I've selected already where the heartbeat rising edge finishes, and the measure time is here, as you can see, 1.041 seconds. So beats per minute is simply 60 times the frequency, which gives us roughly 58 beats per minute, which, you know, honestly does seem reasonable. But I've performed this calculation a few minutes after this recording finished of my finger. So now what I'm going to try to do is to make a sensor which will measure my current heart rate.
Next, I'm going to take my Arduino and I'm going to stick my output, which was previously in my picoscope, into the analog input of my Arduino.
I've written a piece of code for my Arduino. It's about 50 to 70-ish lines long. And basically I have as my output type a processing visualizer, right? And I found on the internet in this new programming language called processing, I found this visualizer, and someone already written for me a piece of code which basically gives me a very nice user-friendly interface. So if I just upload my code to my Arduino quickly, okay, that's done, and we can go to my pulse sensor, we get this very nice, friendly user interface.
Right, so my friend Ankit's been very nice, and I'm very thankful for him. He came to help me out. He's basically got his, how do you put it, around your waist, and then you can, around your chest, okay, and then you can measure on your phone your heart rate. Cool, and then we can compare the actual measurement on his phone to the one we're gonna measure on our laptop. Yeah, it's measuring quite well, as you can see, 65. Here's the finger where it's measuring Ankit's blood. And here's the measurement, if you can read that off the light, 66, it says now 65. There we go. As you can see, it's about the same. Wow, that's actually like spot on. Wow. I didn't realize it worked that well. Wow, well, thank you very much, Ankit.